Good afternoon, everybody. I'll try not to take too much time because I know we're keeping you from lunch. But I wanted to, or was asked to bring a bit of the service provider viewpoint into some of this discussion, and in particular around the use of both licensed and unlicensed frequencies, particularly as we start moving towards 5G, and what does that mean? So I'll try to give you a little bit of some of those thoughts. AT&T, back from the days before we were AT&T, we were to SBC, we've been a pioneer in the use of public Wi-Fi and Wi-Fi in combination with our mobile networks in order to ensure better quality of experience for our customers, better coverage indoors and so forth. And we've been very involved in using Wi-Fi in people's homes for data, but also for video distribution, for instance, in our UVerse system with enterprises and public venues such as stadiums and so forth. So while there has in the past been some concern over, are you a mobile proponent or are you a Wi-Fi proponent? For a long time, AT&T has seen these as complementary. Not competitive, and we continue to see them as complementary. So if you look at the wireless trends, you can look at wireless trends and think about it in many different ways. One of the ways that we've seen lately in terms of more interest has been around IoT and the number of devices. As wireless mobile services become more and more saturated in terms of penetration, we're seeing growth in terms of devices being more in the IoT space, perhaps, than in the handset space. Now, that doesn't mean that's where the growth in data transmission is coming from necessarily. So while we show something in the order of 27 or 22% CAGR for wireless IoT devices, and that's showing the need for efficient use of those devices, the use of data continues to grow at a tremendous rate, with video becoming more and more of what people want to consume on the go. So if I remember it correctly, in the last, I think, 7 years, the data on our network has increased by 150,000%. So a tremendous growth in data, and we don't really see that stopping. And one of the reasons why everybody's been interested in 5G and interested in new technology regime or spectrum regimes, such as in millimeter wave. But by 2020, there are estimates of 50 billion devices being connected to the internet through wireless means. And I think both cellular and Wi-Fi and other technologies are going to be part of that, whether it's Bluetooth or Zigbee or Z-Wave or other new ones that people come up with. When you think about the way these are being addressed, cellular has had the advantage of coverage, wide area availability, and deep penetration and so forth, but it has had the disadvantage of cost because we've had to deal with mobility. We've had to deal with the complexity that comes with mobility. The cellular companies and industry in general has been trying to reduce the cost of that through Category M and Category M1 techniques to reduce capability and cost and reduce the amount of mobility that's made part of those devices. So they're going to address part of that. And of course, as 5G comes along, a big part of 5G is also looking at how do you optimize for IoT. Cellular will also continue to be sort of a gateway, as was mentioned earlier, if you think about it in terms of backhaul, being able to connect a lot of different Wi-Fi devices together and then backhaul that into the network perhaps. So our spectrum reality today, and when we think about the amount of data usage that continues to climb, is the data demand's exploding and its capacity, but it's also peak data rates that people are expecting. And licensed spectrum below 6 gigahertz is getting to be pretty hard to come by. And it's very fragmented. So if you look at what AT&T has, we may have a lot of spectrum in a given area, but a lot of it's in 10 or 15, maybe 20 megahertz chunks. So in order to continue to increase the throughput that we can provide, we're using carrier aggregation to be able to do that. Now that's a helpful technology, but it does increase some of the complexity. Unlicensed spectrum is used in many applications, as we've been discussing, in the home, the enterprise, public, and these need to be used together in a very efficient way. So mobile operators are integrating Wi-Fi to augment the licensed spectrum in addition to what they can continue to do in terms of improving technology and a lot of densification. So there are many, many more base stations out there than there used to be. So part of that, when you think about Wi-Fi augmenting the cellular network, gets to selection of, do I do Wi-Fi, do I do mobile, LTE? And people kind of refer to that as Wi-Fi offload. And, you know, I hate to think of it that way, really. It's a matter of all of the above are resources that we have in order to provide service to our customers. Coming up, we have LTE, LAA, and LWA, which are standardized methods of using LTE and, in case of LWA, Wi-Fi together in a uniform way so that we're integrating that unlicensed use along with the licensed use. So now what happens when we move to 5G? So 5G is going to be a more efficient technology. But when people tend to think about 5G, what comes to most people's minds probably is the use of millimeter wave spectrum and very small cells related to millimeter wave spectrum to get those very high throughputs. But it's going to be much more than that. 5G is going to be a multi-radio access technology design. We're going to have sub-6 gigahertz that can be used in macro cells or in small cells. We'll improve the spectral efficiency with that, and one of the key things that we need to do there is provide control for the millimeter wave systems at the lower frequencies so that we can maintain connectivity and session continuity as somebody is moving around with a millimeter wave system, which may connect and disconnect because of the way that it may be deployed, particularly in the early years. The other thing that we're going to be doing with that is where most of the focus around IoT will be. So if you think about all the devices that are going to need to connect, smart city, all of those things that we're going to want to make part of our overall network and approach, we need a lot of wide coverage with that. And so that's got to be in the lower frequency bands. We're also going to integrate other networks. So you're going to see the 5G radio technology along with LTE, along with Wi-Fi and other things that are treated as different access technologies being used within the same system. So we don't want to use them, they're not purely vertical and separated, they need to be used as a system. And part of what we're trying to do with the core network as we move towards 5G is to become a more access agnostic core so that we can directly connect Wi-Fi, operate LTE, operate 5G, whatever is needed in order to provide the best service. So it needs to have native built-in ability to support the different access technologies, and that doesn't just include wireless, but it includes wireline as well. And so you've seen a lot of emphasis from AT&T on software-defined networking and network function virtualization, and a lot of it's driven around that need to bring these networks together to be able to create the kind of network we need in a given place for a given function and capability. Okay, the other thing that is illustrated in the diagram, as I mentioned, when you think about millimeter wave, and this is going to be in fairly small coverage, 100, 200 meter kind of radius, and you go into a downtown area where you're moving between buildings, turning the corner. It's not quite the same as our lower frequency mobile networks, where as you turn around, your power starts to fall off and you've got time to make that handoff if you need to. As you turn the corner here with millimeter wave or just turn your head, that signal can be gone just like that. So you've got to do a couple of things. You either have to make sure you're covered to that device by multiple transmission points and be able to switch between them, or I've got to use that lower frequency band as my control mechanism. And so that's where we think this is mostly going to be going with LTE or 5G as your control network. and doing control and data, and then millimeter wave opportunistically as you can for the very high speeds. So one of the things that we have tried to impress upon the FCC and others is that we need more spectrum below 6 gigahertz in order to make sure this all happens and continue to be able to address the amount of usage that people want to put on these mobile networks. As you probably all know, right now there's an auction going on with 600 megahertz spectrum. The 3.5 gigahertz spectrum has just had its rules enumerated. There's work going on within WIM Forum, and as part of that, the CBRS Alliance, in order to think about how do we use 3.5, what do those rules look like, how do we coordinate, and then how do we coexist? Because there is no specific definition of technology in 3.5. It can be multiple technologies. Now, if you think about the GAA, so it's a 3-access, as was mentioned before, where you have your incumbents, your military systems, FSS systems, and then you've got a priority access licensed, and then you've got general access use, which in a way you could think of as unlicensed. How do we have systems that coexist, for instance, within that general access layer when they could be different technologies? They may or may not be properly synchronized, and so forth. So there's a lot of work that still has to happen there. We've also been looking at spectrum above 24 gigahertz, as most of you know, with the Spectrum Frontiers NPRM. The 28 gigahertz band and 39 gigahertz band have been allocated now by the FCC. They have not yet set timing or rules around auctions, but we know those will be coming. They also set 64 to 71 gigahertz as additional unlicensed spectrum, and that's directly adjacent to the existing 60 gigahertz band. So now you have 14 gigahertz of contiguous unlicensed spectrum. And there are new bands under consideration now as the further proposed notice of rulemaking. I think there are about 7 different bands that are now working its way through the FCC to determine which of those might make good additional bands and what those rules ought to look like. Again, with the spectrum below 6 gigahertz, though, that's the 600 and the 3.9 is the only thing that's currently identified. So what does that mean as we go on here and we need more capacity and we need a new technology there that will allow us to do very low latency services? And what it's really going to get to in order to handle that massive number of devices, and some of those devices which are going to need extremely low latencies, is that we're going to probably need to use some of the spectrum that we already own today. So just like going from every other generation, 2G to 3G to 4G, we're probably looking at spectrum refarming to make that happen. And there's a lot of work that we're doing right now within 3GPP to allow a level of dynamic sharing between 5G and LTE within the same frequency band. So we hope to be able to minimize a little bit of the pain in doing that. But any help we can get from the FCC in making more spectrum available will certainly be helpful. Now, as we mentioned, or several people have mentioned, with the 3.5 band, one thing we're seeing as an emerging trend, is 3.5 is not going to be unique. It's here, it will do it, then we'll move on, and everything will be the way it was. Most of the spectrum that might be allocated for mobile services currently exists for some other service. And so dynamic spectrum sharing is something that is going to become the norm, not the exception. It's likely that a level of spectrum sharing, whether it be geographical, temporal, or some other form, is going to be the norm, and we're going to have to deal with that. So much of that's being addressed as part of the 3.5 gigahertz band, and trying to understand how we do that. We are finding that to be difficult as an industry to understand how best to do that. But in the 3.5 gigahertz band is supposed to be essentially our experiment. It's to find out how do you do that. So you heard the PCAST report mentioned earlier, and that recommended a spectrum access system that knows where the transmitters are, license boundaries, power levels, and so forth, so that it does calculations on interference and can help guide power levels that a given transmitter can use, when it can transmit, what channel to transmit on, and so forth. So it's being used to govern that spectrum. And that's being pushed into other bands as well as a suggestion. It's being considered for at least 2 of the bands in the Spectrum Frontiers FNPRM. It is unproven. So we've got a lot of work to do to show that this is the right way to go about it. But the Wind Forum and the CBRS Alliance are working that in some priority. So if you look at this kind of from a system perspective, what we really need is a flexible and universal network that will cope with this heterogeneous environment. And so to us, that means an SDN, NFV kind of a network, one that will support network slicing. So I can have multiple logical networks for different services. The capabilities that you need are different, very different, between the ultra reliable low latency IoT and between massive IoT, which may not really care much about latency, and very different from enhanced mobile broadband. So network slicing will help us to optimize our network for those different applications. We also see a lot of convergence between fixed and mobile networking services, and the SDN NFV framework will allow us to do that. And I think communication networks, as you think about that more in terms of verticals, will have to go away. It's really going to be a communication system that you got to think about. We want to provide, as was mentioned before, the customer doesn't care what they're on, how much pain you had to go to get it there, how you coexist with anything else. All they care is that their device and their system work, and they give them what they want at a given time. So we've got to think of this holistically as a system. We need faster service creation and reduced development times, which again, we believe the SDN NFV can help us get to. And system and network management are going to have to evolve to use advanced automation and use big data in order to let us coordinate between these 2 networks, make intelligent decisions about which network or which combination of networks that we want to be using at a given time, and provide the right quality of service and quality of experience for the customer. I believe that unlicensed is going to be a very key part of that future. I think Wi-Fi is going to continue to be a key part of that future. You know, people have talked about LTEU and LAA, and are those things going to drive out Wi-Fi? I don't think there's a prayer of that happening. You think about people's homes, enterprises, where they want to have control over their own environment, and then many different applications where Wi-Fi is the right answer. LAA is not going to be the right answer. So we've got to think of these not as either or, but as an entire collection of technologies that we need to use in the most intelligent way. So Wi-Fi should continue to develop to be carrier grade, and that was glad to hear Edgar's announcement today in bringing some of that together so that we have improved integration, better interference management and interference mitigation. One of the areas I think we still need to work on with Wi-Fi is a more deterministic quality of service, so that when the loading gets high, we don't lose all of its performance. And there is part of the spec that allows us to do that. It's been there for a while, but could probably stand to be revisited. But we need to do some examination of a more deterministic QoS. And so I'll leave it there and be happy to answer any questions.